Welcome back, Math 30-2. Today we are looking at our very first lesson in applications of exponents and logarithms. Now, what we're going to look at is just solving equations that involve exponents or that have exponents. Here we look at it. The first example they give you with the volume, and you're trying to find the radius given the volume with the formula. The problem they come into is it's cubed. Right? It's r cubed, and that's where we have a hard time solving. So we're going to just start off here, and we're going to go over some little examples. So the first example is x to the 1/2 is equal to 7. Now our problem here is we do not like it when our exponent isn't to 1. If I said x is equal to 7, anything to the power of 1, that's easy. We always want our exponent to be 1 to solve for x if it's a variable. So what I'm going to do here is put both of these into equal or equivalent exponents. Okay? Now, what I'm going to do is, we have this so they're equal. So now, what do I do to make this so it's no longer a fraction? Power to square. So it's like squaring it. So I'm going to have power to a power, we get x, and then here we are going to get 7 squared, 2 to the 1, which is going to give me x is equal to 49. That's one simple way of doing it. We're going to try it again with this one here. Now if I look at this one, the only thing to the 1/3 is this x here. That's the only thing. So the 2 isn't to the 1/3, so I'm actually going to move this 2 over. So I'm going to have x to the 1/3. I want to isolate for my x. It's equal to -1 all over 2. Okay? If it was in brackets like this 1/3 would be to both. But it's not in brackets, so we're only to 1. Now, well, this is all to the power of 1. This is to the power of 3, so I want to get rid of it. I can't subtract, because if I subtract, that gives me to the power of 0, and that just doesn't make sense. We're not going to subtract exponents. So I'm going to multiply by 3, multiply by 3. What do I end up getting? I get x is equal to, x to the power of 1 now, 3 over 3 is 1, is equal to -1 over 2 to the 3. Well, I continue solving this. I am going to get this is equal to -1 over 8. Alright? There we go. Now, we're going to look at this one here. So I'm saying we have the 2 over 3, but the 5's on that side. We want to divide both sides by 5. So we want our x by itself. So I'm going to get x to the -2 over 3 is equal to 9. Now, can I solve this guy? I think I can. I'm going to, but that's a negative. I want it positive. So what do I do to get a positive? I have to multiply by a negative. I'm going to multiply this by, well, I want that as a 1, not a 2, not a 3. So I'm going to multiply by the reciprocal. So -3 over 2. So I'm going to multiply this by -3 over 2. Okay? So what we end up getting is x to the 1 is equal to 9 to the -3 over 2. Well, I don't like this being negative. Never like the negative exponent, so I'm going to put this and flip it. Remember, the negative exponent means we flip, so I'm going to get 1 over 9 to the 3 over 2. This one's square rooting, that one's cubing, so I'm going to get 1 over 9, or 1 over 3 cubed, which is equal to 1 over, get that over there, 27, because we have to cube it then. I first square rooted, then I cube. So x is equal to 1 over 27. All right? No problem. Our next step here is we're going to look at the change of base. Okay? So change of base means if I have something like this, 2 to the x is equal to 16, and then 3 to the x is equal to 81. We're just changing the base. So just read this over. The base is this part, so changing the base. So here we want 9 to go to base 3. So let's switch this up. How can we do that? Well, isn't 9 the same as 3 squared? That's equal to 9, right? Now, it's 3 squared to the power of 2 to the x. Now, if we remember our exponent laws from before, we multiply these in. So that's the same as 3 to the 6x. All right? Okay, let's try this next one here. We want this in base 5. Well, 5 to the power of 3 is equal to 125. And all this is 2 minus x. But all that is to the 2 minus x. Now, I have to multiply this 2 minus x into that 3, both of them, because it's 3 multiplied by 2 minus x. This exponent is 3 multiplied by 2 minus x. So the 3 must go into both. Distributive property. 5 to the 6 minus 3x is my solution. Okay? There we go. Now we have this into base 2. It wants this into base 2. But we have two things here. I'm pretty sure both of those could go into base 2. 8 is the same as 2 to the 3. 16, well, that's the same as 4. Or, sorry, 2 to the 4. Must make a mistake there. Got a bit ahead of myself. Wrote the 4 first. 2 to the 4. And this one's to the power of x. So I keep this together. I'm just going to zoom in a bit here a bit. So if I keep this together, what's going to end up happening is we get 2 to the 3 multiplied by 2 to the 4x. Well, what happens if we multiply two numbers that are the same base with exponents? We will add our exponents. So let's add these exponents. We're going to end up getting, we just add these together. Or it could be 3 plus 4x. Okay, so that's in base 2. So we did both of those in base 2. This next one, we want 1 over 512, and it says it wants this in base 2. So first of all, this isn't a fraction. We want it in base 2. So I'm going to go 512 to the negative 3x. Why? Because now we could put it into proper base 2. It's no longer in a fraction. Okay? Next, well, we have 512. How many 2's are in 512? Well, I think that's around 2 to the 8 or so. Oh, 2 to the 9. So that is 2 to the power of 9 is equal to 512, 3x. We can multiply 2 together many times if you want as well. Now, the power of a product, power of a power. So we have this. This is going to give me 2 to the negative 27x. Okay? Second last one. Let's take a look here. We want this to 2 over 3. Well, this in power 2, this to the 2 over 3. This in power 2 is, it's just the top if we look at, that is 2 to the power of 4. So it's 2 to the 4. Now the bottom, well, that should be in base 3. So 3 to the what is equal to that? 3 times 3 times 3 times 3. That's 3 to the 4. So that's 3 to the 4. Look how that works out. All this to the x plus 5. Well, both of these are 4. It's like saying 2 over 3 to the power of 4 all to the x plus 5. So what does this equal to? 2 over 3. Now we have to multiply this in to the 4x plus 20. Just looks like that. Okay? So that's how we do the change of base. We basically want to put everything into the one common base. Alright. Let's take a look at this next few examples. So solve the following equations. So now we're going to try and solve these. Well, if I look at this, this is the same. Oops. So we're going to try and solve these here. So if I look at this, these here are the same, right? My bases are the same. And in order for these to be equivalent, then my exponents should have to be the same, shouldn't they? Well, let's see. So basically, we know if the bases are same, because 5 squared is equal to 5 squared. Well, 5 to the 7 can only equal to 5 to the 7. It can't equal to 5 to the 9. So therefore, my exponents have to be the same. So we can now ignore the bases, since they are similar. We're going to have 2x plus 3 is equal to 7. Now this reminds me way back to grade 9. How do I solve this? We just isolate for x. I'm going to minus 3 from both sides. So I get 4. I get 2x is equal to 4. Divided by 2. Divided by 2. X is equal to 2. Let's take a look at b. We have a problem. This is in base 7. This isn't in the same base. It's hard to solve for that exponent. Well, I think we could put that to the same base. Well, this is the same as 7 to the power of 3. We know it's in base 7, so you could just guess. You could just keep on multiplying 7 to figure out how many it is. Because this is the lowest base. It has to be in that base if we're going to solve these. So 7 to the power of 3. Okay, so let's solve this now. So x minus 2 must equal to 3, because the powers must be the same for them to be equal. 7 to the power of 3 can only equal to 7 to the power of 3. So let's take a look. We have x minus 2 is equal to 3. So x is equal to 5. There we go. Hey, we're solving. Not that bad so far. Looks ridiculously complicated, but it's not that bad. Next one here. Base 3. So this should be in base 3. Well, if I keep on multiplying by 3 to get to that base, I'm going to find out it is 3 to the power of 4. Or 9 times 9 is 81, and that's 2 3's for each, so that's 4 3's. To the 3x is equal to 3 to the 5x minus 1. Okay? So I look at this. Well, that's the same as 12x. And this is 5x minus 1. Because now when I'm on the same basis, I could just look at my exponents. And we solve. I'm going to add 1, add 1. I'm going to get 5. Oh, 5x is equal to 12x plus 1. So now I'm going to, subtract 12x, subtract 12x. So I'm going to get negative 7. X is equal to 1. So then x is equal to negative 1 over 7, because I divide both sides by negative 7, which is the same as negative 1 over 7. Okay? There we go. All right, D. It says 3 to the x is equal to that. So these must be in base 3. If this is in base 3, let's try and put this into base 3. So this side here, first of all, we're going to look at is 27 is 3 to the power of 3. Okay? Well, this is the same as 3 to the 1 over 2. Hey, if I do this, multiplication of powers, well, that's going to give me 3 to the 3 plus 1 over 2 is 3.5. So then, x is equal to 3.5. Because if I add half to 3, that's 3.5. Easy. Okay. So the next one is our word problem. It says, the bacterium triples every 6 days. The number of bacteria n present after x days is given by the formula. So here we just look at the formula, and it wants to know how many days, after how many days will there be 243 bacteria. So we want 243 is equal to 3 x over n, or x over 6, right? So n is x is days, n is bacteria. There we go. So now we need this in base 3. Let's try this out. How many 3's do we have to get there? So I'm going to try 3 to the power of 5 first. Oh, 243. Look at that, lucky guess. 243. So I get 3 to the power of 5 is equal to, 243 to the power of 5 is equal to 3x over 6. Now, that means 5 is equal to x over 6. Therefore, x is equal to 30. So I multiply both of these by 6 to solve for x. And x is equal to 30. Alright? Okay. Last question. It says, consider the exponential function. There we go. And that. Solve the equation graphically using a calculator. So you could just graph this under y1 and this under y2. The next part is solve it algebraically and then find their intersect. But we're going to solve this algebraically and find the intersect. So graphically, we go y1, y2, find the intersect, but we're going to do it algebraically because that's what this lesson's about. So let's zoom back in here. Oh. Alright, so basically, if I look at this, what's the slowest thing that these could be divided by? If I add these together, that's 9. Add these together, that's 9. They could both be divided by 3. So I'm going to get 3 to the 3x minus 2 is equal to, I'm going to flip this first. So I'm going to have 1 over 3 to the 4 x plus 3. Okay, so now we're almost in the same base. So this is the same thing as 1 over this side here, 3 to the 4x plus 12. And this one here is the same as 3 to the 3x minus 2. Now my next problem is, this is on the bottom. We want to flip this. We need to put it on top. So we have to multiply our exponents by a negative. So I'm going to get 3 to the negative bracket 4x plus 2, or plus 12. And this here is going to be 3 to the 3x minus 2. So now we have the same exponents, this and this. Okay? So I'm going to get 3x minus 2 is equal to negative, multiply that negative all by 4x plus 12. So that's going to give me negative 4x minus 12, because I have to do both, and 3x minus 2. Continue solving that. That's easy now. I put this to that side. So I'm going to get 7x. Now I have to move this 2 to that side. I'm going to get negative 10. So then go back up here. And I'm going to get 7x. Just wait, make sure I'm doing it right. 4x, 3x. This is supposed to be a 6. Whoops. My mistake. That's a 6. I forgot to multiply this 3 into both. So that's a 6. 6. Okay, so then we go this, minus 2. So that's not going to be minus 10 because we're subtracting 6. So we add 6, and this is 12. I am actually end up going to getting minus 6. So then we're going to get x is equal to negative 6 over 7. And that's my solution. Okay, sorry about that mistake. I'll see you tomorrow as we work on these together. Good luck.